Hello and welcome to this Haas tip of the day. Now, behind me is a mill, and this is a tool. But to get the most out of our mills and our tools, we have to use the right tool holder for the job. Now, the problem is there are as many different kinds of tool holders out there as there are vehicle types on the road. So we'll ask the question that we know you want the answer to. Which of these holders is the best? And we're going to answer that with a torch and using physics. And we're going to cut some stuff in half. So you do not want to miss what comes next. Everything for me begins with my setup sheet. So check this out. I've got a block loaded up. Now if you're tightening up those tools by hand, if someone asks, what is the best vehicle? You might say the sports car. It's super fast and it costs a lot of money, so it's got to be the best, right? But what if you have to pick up some 2x4s at the hardware store? Perfect. How about 500 2x4s? That's not going to work. How about going to the beach? With a family of 7? No. You get the idea. You got to match the task with the vehicle. And the same can be said of our tool holders. We judge these tool holders based on a bunch of different factors, like price, how much the entire tooling system is going to cost us, balance. That's just how badly the tool assembly is going to shake at higher RPMs. And we've got grip, how well the holder holds on to the tool when roughing and finishing and those sorts of things. We've got clearance. Some tool holders are better at others at reaching our part without running into our fixture. And among other things, we've got run out, which is just how much the tool will wobble in the holder. Now, I just want to mention right now that I'm painting this entire topic with a very broad brush. When I say this holder, I'm talking about this style of holder, this type of holder, not a particular brand. Now, to reinforce this, our legal department has written up this disclaimer. Okay, did you catch all that? Perfect. That's out of the way, on to the holders. Well, let's start with our drill chucks, as drilling is one of the most common operations in machining. Now, they come in two basic styles. We've got a keyed chuck over here, see, because this is a key, and you'll tighten the drill by inserting the key and rotating it tightly. And then these are keyless chucks over here, keyless. You can tighten them by hand. Now, these both have their place. This style of chuck was invented by a fellow named A.I. Jacobs. He patented it way back in 1902, and you'll find them on all kinds of drills, like the drill press in your garage or shop. I actually saw this same style of chuck at a blacksmith shop up in Northern California just last week. Now, if you're a setup machinist, you need to know the difference between these two styles of chucks. As soon as a setup machinist walks in the room, he needs to look at this style of holder and this style of holder and realize that there is a fundamental difference in performance. A keyed chuck, as great as they are, typically has between 3 and 4 thousandths of an inch of run out. That is not what I would call precise, as compared with a precision keyless chuck. Now, this style of chuck, and these are two different brands, typically have about 1.5 thou or 40 microns worth of run out. So my recommendation in general, moving forward, is to load up your machines with precision keyless chucks if you really want to hold tight tolerances with your drills. Now, this style of holder, the keyless chuck, was invented by Albrecht, right, back in about 1908, and they've been popular ever since. Now, I really like drill chucks. I just love them, especially for their range and their ease of use, especially with high-speed steel twist drills. Now, the thing to know about twist drills is that the shank is the same size as the cutting flutes, as the cutting edge, right? So this guy is a 13/32. Now, I had a calculator earlier. I know that this is 0.40625 inches in diameter. So what are we going to hold this wonky size drill in? It has to be some type of holder that's got a certain amount of range to it. Of all the holders that we've got, no single tool holder has more range than these drill chucks. This single chuck right here can hold all of the drills on this table, and it only takes a moment to change the drill. It says right here that this chuck will hold from 1/32 to 1/2 inch, so about 1 millimeter to 13 millimeters. Ooh, did you see this guy over here when you were panning across? This one's pretty cool. This drill looks absolutely horrible. This drill was not tightened well enough, and it spun in the chuck, probably operator error. Now, I would not trust this drill for great run out on important jobs, and it probably scratched up the jaws on whatever holder it was used on. Now, these newer styles of chucks are kind of hybrids. Yes, they're keyless chucks, I can tighten them by hand, but they also come with wrenches that we can use if we just want to increase our grip a little bit. Now, these things are designed to be used with drills, but I would never use them with an end mill. A lot of these chucks, this one here, in fact, is actually two pieces. The chuck is separate from the holder, and these things are held together with friction and a taper, a Jacobs taper, JT6 in this case. We can actually separate the chuck from the holder with the use of a wedge in the same way that we would a drill press. Now, while drilling, these two pieces are being forced together at all times. The drill is pushing up axially and forcing these together. With end mills, the exact opposite is happening. It's trying to pull that tool out because of the helix on the end mill, and it's going to want to separate these two, and nothing good can happen. You're not getting extra grip by any means. Now, if we're running a carbide drill like this guy here, we might run into problems. I personally would not run a carbide drill in a standard style drill chuck. The material is just so hard that it's more likely to spin in this style of chuck. Not that I haven't done it, I've done it a bunch of times, but I just know that there are better options out there. Although Albrecht does make a set of jaws that's got diamond in it, right? So it really bites into carbide or hardened steel drills. I've got to tell you a quick story that I first heard in an article by Kip Hansen. Now, he was talking about Carl A. Bergstrom and how he was the person that invented the helical flute end mill with that 30-degree helix on it way back in 1918. Well, it turns out that putting a helix on the end mill actually solved a whole bunch of problems, so much better than the old straight flute end mills they were using at the time. The tools cut much quieter and left a much smoother surface finish. But they also immediately pulled out of the tool holder. So Carl did what any brilliant machinist would do. He took the tool, he walked over to a grinder, and he ground a big flat on it. Then he tapped the holder for a set screw. So, catch this. Carl Bergstrom invents the helical end mill, and 5 minutes later, invents the Weldon shank. SIDELOCK holder, Weldon holder, end mill holder, all of those names refer to the same thing. And because the set screw style proved so effective, we ended up with a holder that has really incredible grip strength. But because we've ground off a huge chunk of our tool and drilled holes in the side of our holders, this assembly is not typically very well balanced. So what does this mean for us? Well, without a special tool that's been balanced as a matched set, we don't want to run these things above 10,000 RPMs. They'll shake. So balance is definitely not a strong suit for Weldon shank tools, but the price is fantastic, sometimes 5 times cheaper than other alternatives. Remember back with the keyed drill chuck, we said that we might have as much as 3 or 4 thousandths of an inch of run out, while the precision keyless chuck might have 1.5 thou of run out. This style of holder, the Weldon shank, it might give as much as 1/1000th of an inch of run out. That's a lot of run out. And the tooling companies tell us that if we have 1 thou of run out, our tool life might drop in half. That's right, it might drop by 50%. The rule of thumb in the industry is that for every 1/10 of a thousandth of an inch, every 2 or 3 microns of run out, that we're going to lose 10% of our tool life. And yeah, that's probably an exaggerated number, but for the most part, I believe it. So when we're talking about price for this holder, this is a very inexpensive holder, you have to also kind of think about your tool life, and that if you're burning through tools, the holder might be costing you more than you think. Now, what if I have a tap or a drill? Can we hold that in a side lock holder? The short answer is no, you don't want to be doing that, and there's a good reason for it. High-speed steel tools are generally pretty soft, and if you drive a set screw into the side of that tool while in a side lock holder, it's going to dent out or bulge that steel shank, and when you go to pull the tool out, it's going to scratch the inside of your holder. There is a reason why we call these end mill holders and not drill holders, right? We have drill chucks, which are not meant to be used with end mills, and now we've got these end mill holders, which typically aren't used with drills, unless those drills were made for it and actually have a Weldon flat on them. So if you need to grind a flat on a tool to be used in a side lock holder, make sure that you're using the right kind of grinding wheel. The green wheel for the carbide typically, and the other wheels for the high-speed steel. If you use a high-speed steel tool on the green wheel, you're going to load it up and you're just going to get yelled at. What if a car salesman told you that if you paid for the red paint, your car could go 50% faster than the standard blue paint? What would you think? Well, that's really what's happening with modern paint or modern coatings for our tools. If you're machining on aluminum and you're running a TiCN coating, you might be able to push the tool 40% faster with the RPM. If you're cutting on steels, you run a TiALN coating, you might be able to run 50% faster, or maybe double that RPM with that fancy coating. So our tools are spinning faster than they ever have in the history of machining because of these modern tool coatings. And that creates a problem because our tools need to be balanced, especially above 10K. So we want to show you our balancing machine. The balancing process is pretty straightforward. You open the lid, we drop our tool in, and we add in some numbers, and the machine balances things out. It marks the tool with a laser, showing us where we need to remove material in order to make this thing balanced. After it's been marked, we take that holder over to our mill, and we'll remove some material, the amount we were told by the software. We'll then go back, put it in the machine, and re-verify that the tool is better balanced. We were able to remove just a little bit of metal radially from our holder to put it back into balance. But some Weldon holders are so out of balance once they've got the tool in them that you just can't balance them because they really weren't designed to run at those higher RPMs. While we struggled with balance using a side lock holder, a shrink fit holder has none of the drawbacks, none of the character flaws of a Weldon. This guy is perfectly round, smooth all the way around because there's no set screw. It's holding the tool in a different way. Because there's no set screw, the tool itself doesn't need a Weldon flat, so it can be made completely round as well. Round is good. It's easier to balance these things at the factory. Round tool, round holder. When you assemble them, they're still round and they still remain balanced. So this guy can run at the max RPM of your machine consistently without vibrating as much as a side lock holder. For high-speed machining tool pass, which one are you going to choose? The shrink in this case. Now, how do we actually hold the tool in the shrink fit holder? Well, we've got a little physics experiment to show you how. We have a brass ring and a spherical brass ball. Now, at room temperature, the ball does not fit inside the ring. But if we were to heat up the ring, the metal is going to expand. And as the ring gets larger, the spherical ball is going to be able to pass through. With the ring heated, the ball can fit through. Now, if the ball were to go halfway through the ring and we let it cool like that, it would create a press fit and we'd have a hard time getting them apart, which is exactly how our shrink fit tooling works. At room temperature, the tool doesn't fit in the holder. The holder is smaller than the tool. So we take the holder, we put it in the shrink fit machine, and it's heated up immediately by an induction ring. This happens very quickly. We'll hold on to the tool, making sure to wear Kevlar gloves so we don't burn our fingers. Then we'll drop the tool into the holder after it's expanded. At that point, we let the entire system cool, and this can take 10 minutes or more. In fact, if I'm looking at this ring on my table, I'm not going to touch that ring until it's cooled down. I'm going to give that sucker half an hour before I go anywhere near it. With the shrink fit tool holder, that is one of the drawbacks, that if you let it cool down, it can take a long time. The particular shrink fit machine that we've got, though, is special. After the tool holder's been heated, the tool's been dropped in, and the unit is cooled immediately in just a few seconds. When the tool comes back up, we can remove it and it's ready for use. Now, when it comes to cost, the price of a shrink fit holder is actually pretty reasonable, but there's more to it than that. If we had a SIDELOCK holder, all we need to run that system is a single Allen wrench. That's about as cheap as it gets for a tooling system. For an ER COLLET system, we need the ER wrenches or maybe fancy torque wrenches. For the shrink fit holder, though, we need the shrink fit machine. And the prices of the machines just varies greatly. So our price depends on the machine that we're getting. Run out, excellent with a shrink fit holder. Maintenance. Maintenance is about as good as it gets for a holder. There's no moving parts. We might just run a bottle brush down that bore every now and then to get rid of any carbon buildup, but that's it. And another factor is clearance. Some people will go with a shrink fit holder system based on the clearance alone, especially if they're doing 5-axis machining because of that 9-degree included taper on the holder and the small diameter at the nose. You can get really close to those parts, especially with those tilted rotary parts, without worrying about collisions with your holder. The holder is out of the way. Now, a drawback to shrink fit holders is that you need one for every size tool that you plan on running. Now, if I have 10 tools with 10 different size tool shanks, I'll need 10 shrink fit holders. Now compare that to an ER system where a single ER holder can accommodate any of those tools with a simple COLLET swap. So the range on our shrink fit holders, not great. These are not one size fits all. They're one size fits one. Now there are two final things that you need to know when we're talking about shrink fit holders. One has to do with the size, one has to do with the material of the tools themselves. Now, if you already have a shrink fit system, you've got to know this. And if you're thinking about buying a shrink fit system, you need to know this. The first thing we'll mention here is about the size of the tool. The size of the shank of a tool really matters. It affects the grip strength when using a shrink fit holder. And we're going to demonstrate this with a bore gauge. The question is, how much press fit do we really have when we use a shrink fit holder? This holder is 5/8 of an inch, 0.625, around 16 millimeters. So we're going to measure this bore, and we're going to measure the shank on that tool. This is a 0.625 ring gauge. I've got my bore gauge here. We're going to drop this guy in. We are at 0 on the bore gauge. And with my holder, that we've got right around 1 3/10 under, so under nominal of 0.625. So if the tool was exactly 0.625 inches, we'd have about 1 3/10 press fit, or 33 micron press fit. Now, why is this important to know? Because when you're grinding the tool, they grind them to different tolerances. When you make a part for somebody, you have a plus or minus tolerance. The tool guys have plus or minus tolerances as well. Those are called fit tolerances. We're going to make an entire tip of the day on this, but just know this, that the tolerance is so loose with an H8 grind that you'd have no press fit at all. You'd basically be dropping the tool in and out. You cannot use tools that have H8 shanks with a shrink fit holder. So H7, much better, and perfect would be an H6 tool. If you ever have a tool pull out of a shrink fit holder, look at the shank fit tolerance on the tool. That's most likely the culprit. Now, on to this high-speed steel tool. Now, years ago, I would just avoid high-speed steel tools altogether with the shrink fit machine that we had at our shop. The machine heated things very slowly, and it was heating the tool at the same time it was heating the holder. Essentially, they'd grow and shrink at the same time because you've got a tool steel tool and a tool steel holder. They'd be stuck together forever. Nowadays, machines are designed different. They can heat up the holder without heating up the tool, and you can get away with running a high-speed steel shank tool. But make sure you understand this before buying a machine. Some machines can't be run with high-speed steel tools. Other ones can get away with it. Here are the ER holders that we keep talking about. These are the real workhorses of many, if not most, machine shops. They're kind of the utility player of the holder world, and there's a reason for this. They've got good runout, they've got good grip, and as far as versatility and price go, they're fantastic. ER systems can be really cost-effective performers, but I do think that they require a lot more training and care than some of the other holders we're looking at today. Depending on the tool being used and the quality of the holder, they can have really good balance. And of course, if we use the machine, we can get the balance just perfect. So if I had just a couple of tips for you on ER holders, they'd be to make sure that you're using the right size collet for the tool. And that usually means using the smallest collet available for the tool shank. If I'm using a 12mm shank tool, I'm going to use an 11 to 12mm collet, not a 12 to 13. Then make sure that collet is torqued properly. Really affects everything, even the runout. And finally, and most importantly, make sure everything is clean and dry when you're assembling these tools. Now, we've talked about grip strength, and when it comes to ER collets, your choice of what nut you're going to use plays a big part in our grip strength. Some of these nuts, like a low friction nut or a bearing nut, they can increase our holding power by 50%, right? 50% just by using the right nut, which can give all the clamping force right to the taper of the collet. Now, because there is so much to know about ER collets and their holders and running coolant with them and torquing them, we made an entire video on that one subject, and we'll link to it in the description of this video. It is really worth seeing, especially if you're actually a setup machinist someplace. Now, if you're just looking for more grip, I gotta say this a second time. If you're using an ER collet system and your end mills start to pull out, it's almost definitely, within reason, operator error, right? I had this happen to me quite a bit when I first started machining decades ago. And then all of a sudden, I just stopped having problems with ER holders. Why is this? Because I started using the right collet for the holder. I started using the right nuts, right? The bearing nuts, low friction nuts, which is gonna bump up your grip strength and really make sure that everything is clean and dry. So I know I just said that again like 2 minutes ago, but all those setup tips really make a difference. And here, we'll prove it to you. Watch this example. In this example, the holder was not torqued to the proper spec, and it's using just a standard collet nut. Now, after heavy slot milling, the tool has pulled out of the holder and ruined our part. In this example, we used a low friction nut that is cleaned and torqued properly with the same program, speeds, and feeds, and the end mill is held securely throughout the entire job. And if that isn't good enough for you, then we can move on to some of the other holders that have way more gripping strength than an ER system. Now, as your need for better gripping power, clearance, and runout increase, we might find ourselves looking at some of the other high-end holders that were on the table earlier, one of which was the milling chuck, and that's what we're going to look at now. If we were to pull apart a milling chuck, we would find row after row of tiny needle bearings, loosely held in a cage to keep them in place with a special graphite-based grease. The needle bearings ride in between a tapered nut and the tapered holder body. Well, after seeing a holder up close, you might be wondering, what's keeping the nut from just spinning around and around and around like a wheel bearing? Well, check this out. This is cool. There is nothing special about the needle bearings themselves. They aren't even tapered, but the cage that they are loosely held in, it's unique. It holds the bearings at an angle, changing their inclination. When the pins are rotated at an angle shown here by these lines, the pins as an assembly now function like threads on a cap. Now, as we turn the nut clockwise, the bearings that are trapped in between the nut and the body, they start to climb the taper, being pinched between the nut and the body and compressing the body tightly against the tool. This mechanical action gives us incredible gripping strength, maybe 5 times more gripping strength than a standard ER collet. I'll mention this now, that you don't want to tighten up this holder without a tool in it. It could damage the holder, and that's especially true if you have a sleeve or a collet, and that goes across the board with just about any tool holder on that shelf. With our SIDELOCK and our shrink fit holders, we can only hold one exact size tool. But with a milling chuck, we do have a certain amount of range to them. These sleeves are unlike our ER collets. These sleeves are straight, which means if we drop them in and then put our end mills in, they've got nowhere to go, which gives us an even stronger hold when doing heavy milling radially. Now, I'll tend to use milling chucks more often on my 50 taper machines where I need more gripping strength, more torque for bigger cutters. And I think part of the reason I don't use them as much in my 40 taper machines is the tool length. Most milling chucks stick out pretty far from the face of the spindle, from gauge line here. And we know in general, broad terms, that the farther the end mill is sticking out from the gauge line, from the face of the spindle here, the more likely it is to chatter. And we've talked more about that in our chatter video, and we'll link to that in the description. Here's a final thought on milling chucks, and it's how we tighten things up. How we tighten up this milling chuck actually affects the run out of our tools. It matters. Watch this. A good tip to remember when using a milling chuck is how tightening the tool can affect your tool run out. If just doing heavy milling, tighten up the nut until it stops. If using the milling chuck for finish milling, precision drilling, or another operation where good run out is critical, then we'll want to 1, tighten the nut fully, and then 2, back off the nut by just a little bit. Some holder manuals say to back off the nut by 2 or 3 degrees, others by 5 or 10 degrees. Now, the reason they ask us to do this is because when fully tightened, the tiny little roller bearings tend to climb on top of each other just a bit. By backing off the nut just a little, it relieves the strain between the roller bearings and keeps the tool nice and straight. We've looked at holders that hold the tool in place with the use of tiny little jaws or nuts, and mechanical rollers that climb up a steep taper. Even holders that make use of heat and thermal expansion. But the holders on this table right now work in a completely different way. They make use of this. And no, it's not Kentucky bourbon. It's actually hydraulic fluid. The same kind of fluid that you would find in the braking system of your car. These have just fantastic run out, maybe 1/10 of a thousandth of an inch, less than 3 micron. They've got great grip, but they are high-end holders, and their price reflects that. If a salesman's got a tool for you to test, let's say a drill, they don't want you to run it in a holder that has lots of run out. So they might lend you a hydraulic holder to test the tool with, because after it's punched 10,000 holes in unobtainium, I'm going to buy a box of his drill. Now, good tool? Absolutely. But remember, we're testing the tool assembly and not just the tool. Now, one of the benefits of using hydraulic fluid to compress a sleeve that holds the tool is we end up with a holder with really good vibration damping properties. By tightening a single set screw against a plunger, hydraulic fluid is forced through a channel into the sealed chamber around the tool. The high pressure compresses the holder around the tool, locking it in place. Now, like our milling chucks, there are sleeves available that allow us to use different size tools with a hydraulic holder. There are a couple of holders that have made it onto the scene recently that are worth mentioning. One of them is the Power Grip by RegoFix. Now, RegoFix has been around forever. They invented the ER collet system. But that is completely different than what we have here. This system uses a steep sleeve that is pressed into this solid holder. Now, to make this whole thing work, you need a very special hydraulic press. but we've got one. Now, this is an incredibly easy process. We just make sure that everything is clean and dry, like always, like every tool. We'll drop in our sleeve, then we'll drop in our tool. We'll drop in the holder, close the door, and press in. That is it. We are ready to run this tool. Now, this thing has incredible gripping strength. It's got fantastic run out, maybe 1/10 of a thou or 3 micron. And it's got a really nice form factor for 5-axis machining. And of course, they make these with different extensions for longer reaches. But it does require a hydraulic press and special tool holders. This press is an automatic one, while they do have some manual ones available. The final holder on my table is actually a relatively new style of holder, but it's made by a company that's been making holders for a very long time, Albrecht. Now, this style of holder is called an Albrecht APC, but it's been licensed to Amugi as an Amugi FPC and Göring as a Göring HPC, and that's the model I've got here. Now, this is a brand new holder, and I'm not going to cut it in half for you, even though you'd like me to. But that's okay, because they've done it for us in their catalogs. Nice cross-section view there for you, and everybody likes a nice cross-section. This holder requires nothing but an Allen wrench to use, like our SIDELOCK holder, but at the same time, this is nothing like a WELDON. The Allen drives a worm gear mechanism inside the unit, and the use of this steep angled tapered sleeve give this small unit really high gripping forces. Precision-made components give us excellent run out, less than 3 microns or 1/10 of a thou, on par with our hydraulic. Now, these holders are pricey, but like a lot of the other high-end holders, mixing in a few of these with the rest of your holders might make sense. If you've got higher grip strength, you might be able to increase your feed rate, decrease cycle time, make some of that money back. By having better run out, your tools are going to last longer, so you can make some of your money back that way as well. So all this has to be kept in mind when choosing a holder. At the beginning of the video, we told you that we would show you the best tool holder, and I'm telling you, it's here on this table. But after watching this video, you realize that it really depends on your application, what you intend to do with that tool. Now, if I'm opening up a garage shop, putting a mill in my garage this week, I tell you right off the bat, I'm going to be getting a couple of these high precision drill chucks. Awesome, or even a keyed drill chuck if you got the jobs that can make use of that. So I'm buying a couple of these. I'm absolutely buying a bunch of these COLLET holders. These things are kind of like the SUVs of the tool holder world. You got to buy those, and you're going to have some SIDELOCK holders. You might have a WELDON shank rougher that you need to use on some mild steel. So you've got your drill chucks, you've got your COLLETs, you've got your SIDELOCK holders. You're buying those for sure. You're going to start with these basic tools and then add these high performance tool holders as needed. You might buy this hydraulic tool holder that takes almost no tooling. A simple Allen wrench holds it in place, and you'll run that. It's going to work fantastic for you. Then you've got some of these Albrecht chucks, like the APC, that you can walk into one holder at a time. You're going to cross a line at some point. If you do a lot of 5-axis work, you're going to need better tool clearance, right? So if you're using that tapered spherical ball nose end mill porting cylinder heads, you're probably going to buy yourself a shrink fit machine. So you're going to walk into a Rego fixed power grip system or a shrink fit holder system at some point if you're doing that kind of work. But it all depends on how many parts you're running and your particular needs. So there are way too many applications to discuss in a single video, but that's what the comment section is for. Have you tried rough milling with a drilling chuck? How did that work out for you? We'd love to read about that, I really would, in the comment section, so tell us about it. Have you fallen in love with one of the holders on this table, a certain brand or style that works really well for you? Tell us about it in the comment section. Have I said something totally off the mark and just really misspoken and said something ridiculous in this video? Well then, keep it to yourself. No, okay. Go ahead and tell us about it in the comment section. We'll kind of crowdsource the correct answers in those cases. But that is it for this video. Thanks for letting all of us here at Haas be a small part of your success, and for watching this Haas Tip of the Day.